The next two parts are done on the ST38. Again, deep hole drilling, threading, milling. This is the coupling part. Again, a little bit simpler, but various operations in turning grooving and threading. Then we go to the SR20J2. We've got a red acrylic plastic component, and again these side extensions in aluminium. These components here were done on the SR20 R IV, prismatic machining, engraving.
When you look at some of the parts that you're actually machining here, I presume it's very key for a company like yourself to make sure that spindle is turning as much as possible.
Oh, absolutely. It's become a very key machine for us here, yeah, to keep it running, it is very important. And like I say, initially I didn't understand what I was getting with the remote diagnostics, but when they explained it to me, it really is almost a must-have if you're going to have a machine like a Grob.
DataTrack is a modular system. It's not one size fits all. It's there to be scaled to suit any size of subcontract precision engineering business. Whatever their business improvement needs are, we're there on hand to help with the solution.
We've been using DataTrack for many years, but not to its full capability. So now we've embarked on a project which is based around digitalisation and removing the need for paper on the shop floor. There's lots of delays and accuracies with the paper process, so getting that data into the manufacturing system is vital to us.
We've introduced other factors, such as we've done on-machine measuring using the Renishaw probe. That was something completely new to Y. They never used that, but it's integral because we need to make sure we're bringing off quality parts that are within specification. And then we've used a robot, which is, in some ways, it's a longer load and unload time from the gantry loader, but the big benefit here was it's a reduced floor footprint, really, because you can see here, there's not an abundance of floor space.
Underneath the fixed jaw, there's a wedge system that directs clamping forces through the jaw. So when you have a force from this direction from your moving jaw, you have an opposing force in the opposite direction inside the jaw carrier. And what that does, it prevents the jaw from tilting under load. What you have on the moving jaw, on the other hand, is you have a rack that drives this jaw backwards and forwards, and the engagement angle prevents the jaw from lifting when it's under load. So you have two very parallel jaws coming together with no lift and no deflection, so you have very high quality surface contact.
The engineering quest has been about since 1967. We mainly work for the safety critical and quality critical markets.
Do you think you know everything about the Star sliding head SW12 machine? Well, what are we going to learn today?
Well, we're going to learn about how this machine has reduced cycle times by 30% here at Technoturn thanks to the ability to balance turn. And guess what? It's really easy to learn.
And if you like this video, make sure you click on the like, comment, and if you have a question, we'll get back to you.
If I can do 10% of what that guy's doing, I can be like the Rolls Royce of apprenticeships in Thetford. And I think we've reached that now. But what Gareth used to say was, you tell the colleges what you want, not what this is what we're delivering. You tell them what we want. And whenever he had a function or anything, he made sure that the schools and colleges brought the equal amount of male and female to them and everything like that. You know, they as a company can afford to pay a lot more than most companies or whatever. But he had it about right.
Guess what? Star have an exciting competition where you can win one of these. All you have to do is guess the combined cycle time of all of the 16 components here in front of me that make up the Star Saber. In true MTD fashion, obviously we have to find out about the engineering that has gone into the Star Saber first.
I'm Alec Warner, I'm the Operations Manager here at Star GB. This is the Star Sabre. This is Mark III Star Sabre, so we've been doing these since 2016 and we've absolutely smashed it out the park with this version. On this version there's 16 really challenging parts, all done on Star machines ranging from the ST38 down to our SB20 RG. Like previous versions, this version also lights up with the electronics that we've built into it. Regarding the engineering, the most challenging parts are done on the SR38, these two. We've got the body, various machining operations, balance milling, balance turning, engraving included, and the hilt at the bottom of the Star Sabre, again, balance turning, balance milling, lots of milling on the back end. The next two parts are done on the ST38, again, deep hole drilling, threading, milling. This is the coupling part, again, a little bit simpler, but various operations in turning, grooving and threading. Then we go to the SR20J2. We've got a red acrylic plastic component, and again these side extensions in aluminium. These components here were done on the SR20 R IV, prismatic machining, engraving, and finally we've got the shaft component, which we actually did on an SB20 RG, long parts mode, ideal for doing this type of component. We really love a challenge here at Star GB, and this version really pushed the capabilities of not only the engineering team, but our machines as well. So I'll be really interested to see what guesses come in.
It's simple. Click the link below with your cycle time guess and you'll be in with a chance to win one of these Star Sabres.